So once we've calculated the concentration of iron, in your case, I'm using arsenic as an example. Once we've calculated that value, our next step is to use that concentration of iron nitrate and combine it with a solution to see what the absorbance would look like. And to do so, we have this table right here. And yes, it looks really complex because there's a lot of information here. But I think it's pretty simple once you look into it. First, we have the different tubes that we're finding the concentration of. Then we're seeing how much we're diluting each concentration of, or each arsenic, or each amount of arsenic. So once we can figure out how much they're diluted or what their concentrations are, then we can see what their absorbance is at a specific wavelength. And to do this, we need to use the concentration of our original arsenic and then combine it with how much we are diluting it, in this case, to see what our final solution is. And so right here, this piece of code will help walk through this. So this runs a loop, which means that it just repeats it over and over again until it's done. And it takes the original concentration, which we calculated up here. Yours will be different because it's iron, but this one will take the arsenic concentration, which is 0.00035, and then it'll use the new volume. See, we're using a volume of 10 for every single one, so I already input that. And then we know that each of the tubes will have a specific amount of diluted amount of arsenic. And so if we know the original concentration and how much each volume we're putting in, we're choosing 1, 2, 3, 4, and 5, and then we're filling the rest to make sure that all the final values are 10. Then we can use the equation that we solved for algebraically above, which was M1 times V1 divided by V2, to then have this run on each of these values, each of the M1 values and V1 values, and eventually give us the final concentrations of each of these. So it'll fill out these values in the table. So if I run this, these are the values that are found for the final values in the table. And so now we know what each of the concentrations of these are.